compare linear and exponential models. So yesterday we really focused on comparing exponential models with the linear regression. And so today we're doing kind of the same thing. It's going to be the same idea, but we're going to be comparing a linear model to an exponential model. So the one tool that you do need to really use is the Desmos graphing calculator, which you guys are already fluent within. And so I'm just going to go ahead and pull that up because I know it's going to come up. So Desmos graphing calculator. All right, so now it is ready for me when I get to that point. So in this first example, we're going to compare the two salary plans listed by using a graphing calculator. We want to know, will job B ever have a higher monthly salary than job A, and if so, after how many months? So we know job A makes $1,000 for the first month with a $100 raise every month thereafter, whereas job B is $1,000 for the first month with a 1% raise every month thereafter. So in order to kind of do this, I need to have an equation for job A and an equation for job B. Now, if I notice job A, it's $1,000 for the first month with a $100 raise every month thereafter. That is a linear relationship because the $100 is constant. So I know my equation for job A is going to be able to form y equals mx plus b. So keeping that in mind, y equals, slope is how much it's constantly increasing, and we know it's increasing by $100 constantly. So I know slope's going to be 100x plus it starts at $1,000. Remember that y-intercept represents that start value. So there's my linear equation for job A. For job B, it is starting with $1,000 for the first month with only a 1% increase every month thereafter. So that is where we're looking at an exponential function because it's increasing exponentially every single time, right? It's a 1% raise, and 1% is changing, right? 1% of 1,000 is different than 1% of 1,010, which is different than 1% of 1,020, right? It keeps increasing. So this is it's a constant rate, but it's not constantly increasing where it's proportional. So let's think about this. Job B equation, since it's an exponential function, it's y equals a times b to the x, where a is the initial value. So this is going to be y equals a, which the initial value is 1,000. The b is the rate, and this is exponential growth. So I'm going to say 1.01, right? Because remember, this is growing exponentially. It's not growing. Sorry, I'm actually going to use the other tool. It's not growing at a linear rate. It's growing exponentially. So our rate is going to be exponential. So sorry, just because I have that exponent, I'm just going to change how I write it. So y equals 1,000, and then 1.01 to the x power. Now I have my linear equation. I have my exponential equation. I'm going to graph both of these using Desmos. So going to the Desmos calculator, it's that simple. Y equals 100x plus 1,000. And then the other equation was y equals 1,000 times 1.01 to the x power. All right, now notice that I can't see anything, which means I need to change my settings. So again, on the x-axis, I'm going to go from -10 to, let's go to 30. And on the y-axis, there's really no need for these negative values since both of these functions start at 1,000. I'm going to just start at 500, and I'm going to go all the way up to, let's go to 25,000. Let's see if that does anything. A little too high, so let's go to 2,500. Nope, let's go up to 25,000. And maybe we'll change this to 40, 50, 60,
Mommy.
80.
Mommy. Mommy.
Maybe not.
Mommy. Are you? Mommy. Mommy.
What?
Mommy.
Baby.
Mommy.
Hold on. So if I zoom in and zoom out, you can see right here that this is where it crosses at, which is at 363.9666 and 37,396. So The reason why I did that is because, remember, the question was asking if Company A was ever, or Company B was ever going to make more than Company A, because Company A does have that $100 per month, so it's increasing pretty steadily. But Company B is that blue equation. If we look at, at this point, after 363 months, or about 364 months, it does actually start making more money. And as you can see, I did actually include that here. You can see it right there. And so the point of intersection is the answer. So we'll use the other tool. At approximately, you're driving me crazy. At approximately 300, and I think it was 64. Yeah, we'll say about 364. Approximately 364 months. It's a long time. Company B will start to pay more than Company A. So if you're in it for the long haul, Company B would be a really good company to work for. But Company A, like, if you're not, I mean, most people don't stay at their job for more than 5 years anyways, unless they're like really, really committed. Then maybe Company A might be better for you. All right, and then again, look at that essential question. See if you can answer it now. This is a pretty easy unit, so I think you guys got this. I'm pretty confident in your abilities.